Today's artificial limbs are a far cry from the clumsy appendages of yesteryear. Now they are realistic. And thanks to advances in prosthetic technology, artificial limbs function more and more like the real thing. The process starts by measuring the amputee's stump, what doctors call the residual limb. First, the circumference is measured at different points, then the diameter. The limb is protected and lubricated by a coating of petroleum jelly. It's then immersed in algin, a gelatin-like substance that comes from algae. Begun to. A couple of hours later, it's stiff enough to be used as a negative mould. Plaster of Paris is poured in, then a metal rod is inserted. The rod will be used to mount the dried plaster, allowing specialists to work on it. It takes about an hour and a half to harden, then the algin is dispensed with. Then, using sandpaper and files, the surfaces are refined and smoothed. This plaster copy of the residual limb will now be used as a positive mould to cast the artificial limb. There are other ways to create positive moulds. A negative mould is first built using strips of plasticized cloth, much the same way they make a plaster cast when you break your leg. Then a scanner takes a detailed three-dimensional reading and programs it into a computer. A technician then makes any necessary modifications. A plaster block is then placed on a cutting machine. And the computer guides the blade to carve out the positive mould. After either technique, once the positive mould is ready, the artificial limb can be created using a process. First, the mould is covered with fabric socks, some made of nylon, others of a material that contains fiberglass. 6 to 10 socks are used, depending on how rigid they want the artificial limb to be. Then the socks are coated with a liquid resin made of either polyester or acrylic. Here they're using acrylic, tinted to look like Caucasian skin. It's important to ensure the surface is evenly soaked. It's a meticulous process that takes about an hour. The acrylic solidifies in an hour. Polyester takes about 12. Then the plaster mould is broken, leaving a durable plastic shell, called a socket. That will be the basis of the artificial limb. The socket connects to another plastic shell containing the mechanics. Or, like this artificial leg, the mechanism can be modular and covered in just a skin-coloured foam. If the muscle at the site of the amputation still emits a good electrical signal when contracted, the patient can get a myoelectric prosthesis. It has an electrode that captures and amplifies the signal, triggering the artificial hand to open and close.